Hey everyone. So today I want to talk a bit about lightning routing and the price of anarchy. So what is the price of anarchy? Here's a short description from Wikipedia, but overall it's the measure of how the efficiency of a network is affected by everybody acting in a decentralized fashion. So it's mostly the ratio between the efficiency when it's an optimal network and the efficiency when it's a selfish network. So the efficiency, we can, the efficiency is going to depend on what is the network that we are observing. So as a very short example, so let's say efficiency is the average travel time. And we have two situations. We have on the left a situation in which everybody wakes up, they grab their car, they go to work, and the route that they take to get to work is chosen individually by everybody without coordinating with anybody else. And then we have the situation on the right that would be a fully coordinated network in which everybody wakes up, grabs a car, goes onto Google Maps, puts their location, and then Google Maps is the decider in which is the route that they're going to be taking. So in this example, let's say if everybody were to do it the decentralized fashion, they would have 30 minutes of travel, and if everybody used Google Maps, they had now 15 minutes of travel. So this would give you a price of anarchy of 2. Now, when it's the same amount of time, so one side or the other, it's up to the user's choice. And worst case would be if payment success in the decentralized network is very, very low, which would bring the price of anarchy very high, and there's a very high incentive, again, to go into a fully coordinated network. So a selfish network. So right now on Lightning, every node takes care of doing its own routing. So every node is storing a full graph of what the network is, and they also store locally collected private information. So public information would be everything that is on the graph. So we're talking channels, edges, the fees that they're charging, the capacities of the channels, and then depending on the Lightning implementation, it can vary what is the private information that it's storing. For example, I know LND is storing previous attempts, I believe Core Lightning as well, in which when it's trying to do the payments, as soon as it sees a failure, then it registers into its database, like we had a failure on this edge, maybe let's try another route at somewhere else, right? Then we have balance estimates. That is something that is coming to LDK, in which LDK is keeping track of, it sort of buckets capacity into 8s and keeps track of where that capacity is for certain channels, like in a historical fashion. That way it can decide, it tries to route through some channel, for example, and it says, okay, normally this channel is in this bucket of liquidity, so I am going to be able to, with a high probability, to pay through this channel or not. And then there's uptime that is also valuable. If you want to do a payment, you want the peers that are along the route to have a very high uptime so that there is no issue with your HTLCs. Now, in this selfish network, all these nodes are using all of this public and private information that they're storing on their node to do a source-based routing. So it's mostly you have this network of a lot of nodes, a lot of edges, and you want to get from your node, that would be the green dot, you want to get to the end, that would be the red dot. Everybody would figure out individually what is the best route for them to take, and it is done by every single node on the network. So everybody's trying to figure out what is the best route they want to take without coordination with anybody else. So source-based routing has the issue that you do have to keep a very big image of what the graph is. You need to know which are the channels, which are the nodes, the most up-to-date fees, capacities. This all has to be stored internally in your node so that it has the decision-making ability to decide which route it wants to take, right? And of course, it's also very resource-intensive. So just the fact of building out this image, you need a lot of gossip. All nodes have to gossip between each other. They need to communicate which are the channels, which are the nodes, what is viewable by their peers, and all of this gossip is very bandwidth intensive. And then of course you have then the full pathfinding algorithm that is computationally expensive, in which you need to try multiple routes until you're able to do a successful payment. So in addition to this, routing nowadays is even getting more complex, it's more sophisticated, and it's getting even more competitive in the sense that the Lightning Network by itself is already growing. So nodes, channels, they are increasing in amount, so this means that every node now has to keep track of more information of what the graph is looking like. There's also new node management techniques that have been appearing. I'm guessing you guys know about zero-fee routing. So this is a node that popped up some months ago, and he came in with the idea that he wasn't going to charge fees at all, right? Everybody was trying to optimize, like, I want to set my fee rate, my base fee. He just came in, sent everything to zero, and said, I'm not going to charge anything. I'm just going to charge for opening channels. So all of these strategies then start to affect everybody else because we're all competing to be able to route payments, right? And then there's some additional tools like LNDG that is an automation tool. You can give it some, like a config file, some parameters, and say, like, I want to rebalance, I want to figure out which are the best routes I want to do. And these are all tools that have been appearing that further sophisticate the management that nodes are taking into account. And now we also have a lot of channel fee changes that have been in discussion that want to be added into the protocol. So, for example, one is zero base fee. So this is from René Picard. His idea is that for this algorithm of finding the route, it would be much simpler if we take out one variable, which would be the base fee. So his suggestion is everybody should use zero base fee so that the equation to find a route is faster than it would be if we had both of them. Then we have fee cards. This is from Core Lightning, and the idea is that the fee that you're going to charge in a channel is going to depend on where the capacity is in that channel. So you sort of, you give like 4 sections. So you say like, when the channel is fully on my side, when it's fully remote, and then like 2 parts in the middle. And when a payment is going to route through there, depending on in which of these sections the capacity is, you would charge the fee that would be specified for that section. So we sort of move from having the fee rate and the base fee into now having fee rates and base fees, but for 4 different sections of capacity. And then finally, there's the inbound fees. This is currently a PR in the LND repository, and what it specifies is that you now can not only define what you are going to charge when you're pushing a payment through a channel, but you can also charge depending on through which channel it's coming in. So all of these conditions are now making more sophisticated and more competitive the full algorithm that you need to do to be able to route a payment through the network. And and the last one is probing, that there are entities that then try to find an edge for their routing algorithms, in which they go out, they probe the network, they try to figure out where the capacity is in different channels, and maybe find like a small edge that they can take advantage of for their routing algorithms. So the issue with Lightning is if we go into a fully coordinated network, into the one that has like the all observing God that decides where payments are going, well, we lose all privacy, because then there is a single entity or a group of entities that then is deciding where payments are going, how they should get there, what fees they're going to pay. We lose all this centralization basically, and there's going to be a group that knows everything that's going on. So how can we take a step towards being a more coordinated network without a full loss of privacy, right? So there is trampoline payments, and what trampoline payments are is that, let's say you have, again, this same network that is composed of a lot of nodes, a lot of channels. You have your node is the green one, and you want to get a payment to the red node. Now the issue is that the green node, let's say, is a very new node on the network, so it hasn't had time to fill up its database of what is going on, which channels there are, which nodes there are. So it wouldn't know how to get a payment as efficiently as possible to the red node. So what it can do is find this purple node, and this purple node, what it does is offer the possibility of doing pathfinding for the green node that does not know what the graph is looking like, right? So the purple node, he does know what is going on in the graph. He's been there long enough. He knows what channels there are, what nodes there are, and he can offer the green node to then tell him, like, send me the payment and I'll take care of pushing that payment over to the red node, right? So that green node didn't have to learn about everything that is going on in the graph. And for example, if you think about a mobile node, right? The mobile node probably has lower storage capabilities, so it isn't able to store a full graph, and if it continues on growing, then it becomes even more hard to keep track of everything that's going on. So this is what a trampoline payment would be. It's sort of outsourcing that pathfinding capabilities that some other nodes might not be interested or might not want to do. So that trampoline node can then be, since it knows that it is like its full focus is towards pathfinding, then it can optimize towards that. So we have, for example, optimized resources. So they know that it is a very resource intensive job. They know that they're gonna have a lot of computational expense. So they can do a lot of caching. They can maybe cache routes that are popular. They can cache which nodes have high uptime. They can improve and optimize the process of finding this path. Then, of course, they can do a lot of route enrichment, which would be sort of how every node is also storing some private information of which are like good nodes to pass a payment through, or which are good edges. This node can also optimize towards that. So it can store previous attempts. It can say, we had these previous attempts to pay these specific nodes, so we're going to keep track of which are the routes that were successful here. Maybe we had some failures in some parts. We're also going to store who created that failure so that we can take it into account for future payments. Of course, reputation, which would fall sort of under the same category, in which if they try to push a payment through you and your node for some reason fails or does not push the payment successfully, then you take a reputation hit. I think this is something that is already done in LND. So as soon as your reputation is hit, for further pathfinding algorithms, it will sort of not take your node into account. We have shared balances, in which you're able to share what is the capacity on your channel. So what is the local, what is the remote? And what this causes is that now you don't have to guess if you're going to be able to pass a payment through that channel. Your probability goes to 1 because you already know if it is possible or if it's not possible. And then there's future liquidity projections, which would be sort of how Google Maps can tell you, like, in 50 minutes this road is going to have high traffic. Then it's something similar, in which you can say, like, okay, like during these times of the day, there's a lot of payments that are going through these channels, so we need to find another solution, since we don't know right now, but most probably in the future, there is going to be liquidity issues here. And this could also be interesting, for example, for merchants or for people receiving payments, so that they are notified beforehand if they're going to have liquidity issues, if they're going to have problems receiving payments from others. Now, this node also has, it's been there for some time, so it has a full view of the network. It can store however many channels, however many nodes it's set up to do. It can have everything up to date. It can have multiple gossip listeners across the network. So it can have the most up-to-date image of what the graph is looking like. So when somebody tries to push a payment through them, they're going to know what is going on, and they're not going to fail because they saw an incorrect fee or they saw an incorrect balance. And then finally, there is coordination. Of course, this depends on the amount of volume that is going to go through that node. If it's able to receive enough volume, then it can also decide, like, we can maybe group some transactions to go through some route, takes other transactions through another route, sort of how Google Maps, if there's this point of traffic, it will sort of give you like alternative routes. So like maybe choose these other routes, it will be more efficient for you. So at Amboss, we're currently working or iterating on doing this shared balances and the future liquidity projections. And we've done multiple iterations. So our first iteration was focused purely on the state. So we allowed users via a client, that we allowed them to push balances to us. And the issue was that we were storing these balances indefinitely, which we got feedback for it. And it meant like it sort of brings our database into being a honeypot of information. We could like sort of get subpoenaed to figure out what are the channel balances across the network, and have like full historicals of what the balances were, which then breaks the like transaction level privacy, in which if you have enough people reporting these balances to you, then you're able to figure out like, okay, like 100 sats moved here, where did those 100 sats move across the network, and figure out origin and the source of those 100 sats, or figure out where that transaction was going, who created it, and where it ended. So we got some feedback for this, and we're currently working on a second iteration for it. So it's more focused on the short-term state and the long-term flow. So what we're doing is, first on the client side, or the service that is pushing these balances to us, we are adding more configurations so that the user is able to refine better what is the information that they're going to be sharing to us and at which intervals they're going to be sharing it. So sort of obfuscate a bit, not provide as in detail information of what their channels are looking like, but still allow them to have some reporting that might be useful for them to do some liquidity management. And after a certain period of time, we grab that like raw channel data that is specifically sharing like what their capacity is. We aggregate it and we store just the aggregation into our database. So it still has a risk in which there's still a short period of time in which the raw channel information is still in our database. But we continue iterating. We take a lot of feedback for this, and we'll see if we get a third iteration out. So yeah, so going back to the incentives with the price of anarchy, we see that if the price of anarchy is too high, then there is an incentive to move over to a fully coordinated network. We do want to have the most efficient network for everybody, so there is a tendency to go in this direction. And on the contrary, if the price of anarchy is too low, then there's an incentive to move into a fully decentralized network, since you just get a better efficiency by not having anybody coordinate anything. So of course on the Lightning Network, ideally we would move into the fully decentralized version, but it is not going to be useful for everybody. If you think about different use cases that people would have for using Lightning, for example, if you have your own Raspberry Pi at home, you set up your Lightning node on it, and you're going to be using purely that as your payment source, then you might be able to sacrifice a bit of payment reliability and speed just to ensure a higher privacy level. But on the other side, imagine somebody has a Lightning node on their phone. They might be willing to sacrifice a bit of privacy to ensure payment reliability and speed when they're interacting on Lightning. Nobody likes going to the beer tap and waiting for 5 minutes to get their transaction through, right? So it's all about finding correct incentives so that all the players and all their use cases on Lightning have the full benefits of this network, and we work to improve the experience for all of them and not focus specifically on some. We do want to cover as much use cases as possible with this payment network. Yeah, and that's it. So this is me. That's my Twitter handle, and thank you very much. If anybody has any questions? Yeah.
There is like actual data about what is the rate of the Lightning Network at this moment?
The what, sorry?
There is the number, I mean, the rate of how is the Lightning Network behaving?
In regards to if we're fully coordinated or fully decentralized,
Yeah, exactly. Like
so I would assume it's more towards the decentralized side, but then you can see, for example, Async with their node and their Phoenix wallet, they do act sort of as a trampoline node. So it is moving in certain cases more towards being like this coordinated network, but yeah, it depends really on who's using it.
I have a question. Is there a way that your users at the Ambos side kind of mark that their nodes are configured in a way that they are trampoline nodes, so that maybe this makes the other people, the other node operators, actually make a channel?
So the trampoline functionality is something that has to be done directly on your node, so that it's able to first communicate with its peers that it is something that it offers. Something that can be done on the Amboss side would more like show publicly which are the trampoline nodes and help, for example, a new wallet or a new node that pops up to maybe get the gossip necessary for it to like fill out its near, the trampoline nodes that are near that node, so that it can start doing payments pretty quickly. So I don't run a trampoline node. I don't know how much overload. You sort of are optimizing the node for being like a pathfinding service, right? So it will, like, it's up to you how much overhead you want to put on it, because it's a service that you're going to offer, right? And if somebody else says, like, I want to use this node for pathfinding, but that node really isn't doing like the service that you're paying for, then they'll probably move over to another node that maybe has like fully optimized caching, storage, all the good stuff.
I always want to do is like crush your Raspberry Pi to spare hardware or something.
It would be a nice test. Yeah. Cool. Thank you very much.